So suppose I have a set here called domain of a function, and I have codomain of a function. That means another set. So suppose I have more element here than here. Then what's the definition of function? A function is everybody here has to map to whatever thing here. Okay, so if I have more things in the domain than the codomain, then it's very trivial that there will be one object pointing to one of the object here that has already been pointed by somebody else. So that's the idea. And in pigeonhole principle, basically they are saying that there are many pigeons and you have many pigeonholes. If number of pigeons is more than the number of pigeonholes, then in the pigeonholes there will be one pigeonhole have two pigeons. So that's the idea. And if the number of pigeon and the pigeonhole are the same, then it's possible that each pigeonhole have only one pigeon. And suppose if you have more pigeonhole than pigeons, then you have some hole have no pigeon. Pigeonhole principle is that if you put n pigeon into n pigeonhole with n larger than m, then at least one pigeonhole must contain more than one pigeon. Okay, to be exact, that pigeonhole contains n minus 1 divided by m floor function plus 1 pigeons. For example, you have 5 pigeons into 2 pigeonholes. I'm doing brute force of listing all the possibility. For example, all the pigeons go to A. So A has 5 pigeons. And the pigeonhole principle is saying that there will be a hole at least 3 pigeons. So yeah, this is true. And then if 4 pigeons go to A and 1 pigeon go to B, then we have A have 4 pigeons, which 4 is larger than 3. This is true. And if I have this, that means 3 pigeons go to A and 2 pigeons go to B. Still, we have 3 equal 3. Okay, that's still true because at least 3, that means I have including 3. And the remaining 2 cases is just mirror image of the case A. So this is true. Another example, suppose I have a group of 13 people. We have 2 or more who are born in the same month. So what's the pigeon? Pigeon is 13 of people. Okay, pigeonhole is 12 months. So in the worst scenario, the person 1, person 2, person 3, up to person 12, they are all in different months. Then for the 13th person, this guy must be within one of them in the same month. Let's say this guy born in July, okay? Then this guy will born in the same month as the person 7. So this is true. In a group of n plus 1 people, each body shake hands with other people, okay? A non-zero number of people in a group, okay? We can find at least 2 people who shake hands with the same number of people. Actually, this is called handshaking lemma. So suppose I have 3 people, okay? If I draw these 2 shake hands, and then let's say I draw these 2 shake hands, so how many people have this guy shake? 1 people, which is this guy. Okay, this guy has shake hand with 1 people. Okay, this guy has shake hand with 2 people. The question here is saying that we can find at least 2 who shake hand with at least the same number of people. So this guy has shake hand with 1 person. This guy also shake hand with 1 person. So they are the same number of handshake hand. So this is true. Okay, and this is true for whatever number of people. Suppose I have a figure like this. Person A shake hand with person B shake hand with person A and also person C, and person D shake hand with person C only. So how many hands has person A shake? 1. How many hands has person B shake? 2. How many hands has person C shake? 2. How many hands has person D shake? 1. So you can see these 2 guys, same number of handshaking, but also these 2 guys has the same number of handshaking. Okay? Suppose B also shake to D. This guy shake to 1 person, this guy shake to 2 person, this guy shake to 2 person, this guy shake to 3 person. Again, there are 2 people with the same number of handshaking. So now let's say I do this. Okay? Then this person shake to 2 people, this person shake to 2 people, this person shake to 3 people, this person shake to 3 people. Now you see, 2 persons have the same number of handshaking. 2 persons has the same number of handshaking. This is still true. If I complete this like this is called a complete graph. Okay, everybody shake hand with other people, so everybody shake hand with 3 other people. So all of them share the same number, and the statement is saying that there are at least 2, which is true because I can always find 2 people with the same number of handshake. Consider this example. For any choice of 10 number in 1 to 19, there are 2 that add up to 19. Okay, I should make it clear. Should be any 10 distinct number. Okay, distinct number. That means you have to choose any pair with no repetition. Okay, you can see each of them add up to 19. So that means what? I have 118, 217, 316, and so on. Okay, and then what? How many of them? I have 9 of them. But now I'm going to select 10 number. So that means if I select 10 number, okay, I'm going to select 10 number. So let's say my number are A1, A2 up to A9, A10. So in the worst scenario, A1, A2, A3 up to A9 are in each specific boxes that add up to 19. But now I only pick one of the number. So for the last guy, it has to enter any one of them. Then that particular bracket will have a number pair add up to 19. So this is true, okay? This is saying that the pigeonhole principle can be used to show this is the case.